Good morning, my dear students. In this video presentation, as usual, we will discuss some more problems meant for students of class 12 of CBSE. The first problem goes like this. Find the area of the ellipse x square by 25 plus y square by 16 is equal to 1 using integration. This is the question, just see. Find the area of the ellipse x square by 25 plus y square by 16 using integration. This is the question given to you. Just see here, the ellipse x square by 25 plus y square by 16 is equal to 1 is the ellipse with center 0, 0 passing through 5, 0, minus 5, 0, 0, 4, 0, minus 4, and it is symmetric with respect to both the axes. Just see here, when y is 0, x is plus or minus 5. Therefore, it passes through 5, 0, minus 5, 0. When x is 0, y is plus or minus 4. It passes through 0, 4, 0, minus 4. When x is replaced by minus x, equation remains the same. Therefore, it is symmetric with respect to y-axis. When y is replaced by minus y, the equation remains the same. Therefore, it is symmetric with respect to x-axis. These are the things you are supposed to remember anyway. Now, x square by 25 plus y square by 16 equal to 1 implies y square by 16 equal to 1 minus x square by 25, which implies y square equal to 16 by 25 into 25 minus x square. Therefore, y will be 4 by 5 times root of 25 minus x square. Therefore, diagram will be like this. It is more flat along y-axis. This is my point 5, 0. This is my point minus 5, 0. This will be 0, 4. This will be 0, minus 4. I just shade the region only in the first quadrant. I will explain why it is so. Due to symmetricity of the curve with respect to both the axes, okay, a required area is equal to 4 into area of shaded portion in the first quadrant. See the diagram. The area here is the same as here. Here all the 4 areas are equal. Therefore, I'll write it as integral 0 to 5 y dx, where my y I already obtained 4 by 5 root of 25 minus x square dx, sorry, not dx, let it be, which is 16 by 5 integral 0 to 5 root of 25 minus x square. Just recall the formula, x by 2 root of 25 minus x square plus 25 by 2 sine inverse x by 5 0 to 5. Here anyway 2 can be cancelled out. I'll get 8 by 5 outside. Apply upper limit, I'll get 0. This is 25 sine inverse 1 minus lower limit, I'll get it to be 0. Therefore 8 by 5 into 25 into pi by 2. This will become 20 pi square units. 20 pi square units. I'll just repeat the whole process. The ellipse x square by 25 plus y square plus 16 equal to 1 is the ellipse with center 0, 0. This is my center. And passing through 5, 0, minus 5, 0, 0, 4, 0, minus 4. When y is 0, x is plus or minus 5. When x is 0, y is plus or minus 4. Therefore, I get these points. Okay. Then it is symmetric with respect to both the axes. When x is replaced by minus x, equation remains the same. Therefore, it is symmetric with respect to y-axis. When y is replaced by minus y, equation remains the same. Therefore, it is symmetric with respect to x-axis. Now bring y in terms of x, I get it to be 4 by 5 root of 25 minus x square. Draw the rough diagram. It should be rough, but at the same time it should be meaningful. Okay, symmetricity should be justified while you draw the diagram. Now, due to symmetricity of the curve with respect to both axes, the area covered here is the same as area covered in all the remaining 3 quadrants. Now, 4 times area of the portion in the first quadrant, shaded portion in the first quadrant. Now, for 4 into the 0 to 5, this is the curve for which I'll get y in terms of x, which is 4 by 5 root of 25 minus x square we have seen. 4 into 4 is 16 by 5. Applying the formula here, integral root of a square minus x square is x by 2 root of a square minus x square plus a square by 2 sin inverse x by a. Instead of a, I have 25. X by 2 root of 25 minus x square plus a square by 2, 25 by 2 sin inverse x by 5. Then 2 can be cancelled out, I'll get 8 here. 2 8s are 16. Over 8 by 5, 25 minus 25 becomes 0. 25 sin inverse 1. Minus here 0, sin inverse 0 also 0. 25 into pi by 2. Here I have to cancel, I write 5 here, sorry. Then 2 4s are 8. 20 pi square units. You can easily check the answer. Listen carefully. Whenever a general possibility x square by a square plus y square by b square equal to 1 with a greater than b. Why I am saying a greater than b is then it will be more flat along x axis. If b is greater than a, it will be more flat along y axis. It's not a big deal. The final answer will be pi ab. Here instead of a I have 4, instead of b, a I have 5, instead of b I have 4. Pi ab, 5 into 4, 20, 20 pi. Therefore I can easily verify whether my answer is correct or wrong. I can easily verify whether my answer is right or wrong. It's easier to verify with a general possibility. If you remember the general possibility, you can check the final answer in your CBSE after doing everything systematically the way it's being done by me now. If it is in a competitive examination, you'll be able to put a tick mark. Pi AB, 5 into 4, 20, 20 pi. It is x square by 9 plus y square by 4. 2 3s are 6, 6 pi. 4 square is 16, 3 square is 9. Oh, sorry, 16, 9 if it is there, let us imagine. For 3 4s are 12, 12 pi. What is A, what is B, you identify accordingly. Pi AB will be the final answer. The next step goes like, next question goes like this. Evaluate, it's also a very standard problem. Integral 0 to pi by 2 sin power 120x dx by sin power 120x plus cos power 120x. I just take it as I name it as 1. Also I is equal to integral 0 to pi by 2 sin power 120 pi by 2 minus x dx by sin power 120 pi by 2 minus x plus cos power 120 pi by 2 minus x. The rule behind this particular step is integral 0 to a f of x dx is 0 to a f of a minus x dx. This is the application. Now for every, you might have seen even in 10th standard, sin 90 degrees minus theta is cos theta. Now for every sin becomes cos power 120x dx by cos power 120x plus sin power 120x. Denominator a plus b is the same as b plus a. Denominator the same. Add 1 and 2. I'll end up with 2i is equal to integral 0 to pi by 2 sin power 120x plus cos power 120x by sin power 120x plus cos power 120x. This will get cancelled as it is. Don't cancel sin cos separately, it's meaningless. They both get cancelled as it is. Summation will get cancelled. 2i is equal to integral 0 to pi by 2 dx. 2i is equal to x 0 to pi by 2. 2i is equal to pi by 2 minus 0. 2i is equal to pi by 2. I is pi by 4. Now for integral 0 to pi by 2 sin power 120x dx by sin power 120x plus cos power 120x will be pi by 4. Let me just repeat the whole process. I take it as I, name it as 1. Also I equal to 0 to pi by 2 sin power 120 pi by 2 minus x dx by sin power 120 pi by 2 minus x cos power 120 pi by 2 minus x. Application 0 t f of x dx. I missed out dx, sorry. F of x dx is integral 0 to f of a minus h dx. Instead of a, I have pi by 2 here. Instead of f of x, I have the whole lot here, except dx. Now, sine 90 degrees minus theta is cos theta. You might have seen even in 10th standard. Here, I wrote it in terms of radian measure pi by 2. Sine becomes cos. Cos becomes sine. Denominator is the same. If you add, I'll be able to add the numerator. A by c plus b by c can be written as a plus b by c. Here everything gets cancelled. Don't cancel sine cosine separately. Please don't do that. Cancel fully. Integral dx is x. Apply upper limit, apply lower limit. 2i happens to be pi by 2. I happens to be pi by 4. The power can be anything even here. If I get a general case 0 to pi by 2 sine power nx dx plus sine power nx plus cos power nx. Apply the rule systematically. I'll get the same answer pi by 4. N can take infinitely many real values. My n is nothing but 120 here. Even if it is given as 0 to pi by 2 cos power 120x dx by sin power 120x plus cos power 120x, same, apply the same rule, proceed. I'll get the answer as pi by 4. Therefore, there are 4 different possibilities. Integral 0 to pi by 2 sin power nx dx by sin power nx plus cos power nx, or integral 0 to pi by 2 cos power nx dx by sin power nx by cos power nx, or integral 0 to pi by 2 dx by 1 plus tan power nx, or integral 0 to pi by 2 dx by 1 plus cot power nx. In all the 4 possibilities, applying this particular rule, I'll get the answer to be pi by 4. In CBSE, do them systematically like this. In competitive examinations, put pi by 4 quickly as the answer. I'll just repeat the 4 possibilities if you want. 0 to pi by 2 sin power nx dx by sin power nx plus cos power nx, or integral 0 to pi by 2 cos power nx dx by sin power nx plus cos power nx, or integral 0 to pi by 2 dx by 1 plus cot power nx, or integral 0 to pi by 2 dx by 1 plus tan power nx. In all the 4 possibilities, applying the rule 0 to a dx equals 0 to f of a minus h dx, I'll get the answer as pi by 4. N can take infinitely many real values. Here apply cos by sine, it comes under this possibility. Right, this is sine by cos, it comes under this possibility. Therefore, this you can remember to apply in your competitive examinations quickly, and in other cases you have to do systematically and check the final answer whether it is pi by 4 or not. In fact, I should say you have learned infinitely many problems by having infinitely many real values for n. Here, the problem which I have done, n is 120, n can be 3 by 2, n can be 5 by 4, n can be 1 lakh, n can be 3 by 5, n can be 350. Anything can be given in all the 4 possibilities. My answer will be always pi by 4. Remember the rule carefully. Learn the rule. Learn the concepts. That's more important than simply learning the particular problem. I'll check for the corrections. If there is any, I'll add up. Otherwise, I'll upload as it is. Thank you, students, for patient watching.